Hello everybody. My name is Furkat and today I will be talking about the paper Context-Aware Group Captioning via Self-Attention and Contrastive Features by Lei et al. Uh, During the preparation for the presentation, I learned a lot of good things, so I hope it will be useful for you too. So let's start. Well, this is my content, and here in the introduction part I will be talking about mostly about the research problem and also the main contributions of the paper, and in the related work part of the presentation I will try to explain briefly about attention model proposed by Vaswani et al. And also in the datasets part we will be talking about two datasets, conceptual captions and stock captions datasets, and also the way how they have the authors have made these datasets. And in the proposed method we'll be talking about main building blocks and also baseline model. And after that we will discuss the experimental results and how they have achieved these results, and in the end we will do conclusion. So first of all, it would be appropriate to understand what is image captioning and what is context-aware image captioning. So what is the difference and what is the similarity between these two techniques? Well, image captioning is a vision plus natural language processing problem. We are given an image like this and we have to come up with a description of the image, like this beautiful girl in the field. So this is called image captioning. And in the current paper, we have another problem, context-aware group captioning, which is partly group captioning, but here we have got a context of images, which is woman in our case, and also we have got a particular group of images within the context, like the images in which we have got women with a hat. So this is called target group, and the overall group is called context group. So our task is we have to give woman with cowboy hat a description for our target group. So, and the real application of this algorithm is suggested by the authors is that it's good for suggesting query for online image search. Well, the contributions of the paper are threefold. First of all, they have come up with new task, context-aware group captioning. This kind of problem was not proposed before, so it's novel problem. And also they have built two large-scale datasets to tackle their problem. First is conceptual captions dataset and stock captions dataset. Well, conceptual captions dataset, it is already existing public dataset for image captions, but they have made another particular dataset on the top of this conceptual captions dataset. And the second one, stock captions dataset, was created by the authors from zero. So they have created this dataset on their own. And in the end, they have proposed a good model to tackle this problem. Well, to summarize the information of the target and context image groups, they are using self-attention, and also to identify the difference between two image groups, they are using contrastive features mechanism. And about them we will talk in the next slides. So first of all, it would be interesting to talk about self-attention, because one of the building blocks of their model or method is self-attention layer. And I will try to explain about the self-attention layer in one slide briefly. So first of all, we have got inputs. Let's say in our case we have got in our target group we have got like 5 images, so we will have 5 inputs, and after that we will use these 5 images as an input to our ResNet 50 model, pre-trained ResNet 50 model, and we will get 5 feature maps for each image. And after that, we will use these inputs as input vector, like if1, if phi1, phi2, and phi3. And after that, we will initialize our query matrix and query vector, WQ and BQ, key matrix and key vector, WQ, WK and BK, and value matrix and value vector, WV and BV. And after that, we will compute our query vectors by linearly transforming our input, phi1, phi2, and phi3. So we are multiplying phi, our input, by WQ plus BQ, which is bias, and we will get our query vector. And after that, we can get the same key vectors in the same way by linearly transforming our input like this. And then we will identify our similarity matrix E. So we will multiply our query matrix to our key matrix, transpose it, and we will get our similarity matrix. And after that, we will use softmax. And after that, we will get our attention weights. Attention weights are the results of our softmax of our similarity matrix. And after that, we will create our value vector by linearly transforming our input vector. So, and after that, we will get the output vectors by multiplying our value vectors to our attention matrix or vectors, we can say. The computation will be like this. So we have got v1 times e11 times plus v2 times a12 plus v3 times a13, and we will compute the sum and we will get our y1, so the first output. And we will do the same, like v1 times e21 plus v2 times e22 plus v3 times e23, and we will get our y2 and y3 and so on. So this is how self-attention model works in briefly, but here I have skipped embedding part, so I don't think it's important here. But if you want to learn about this attention model in detail, I would suggest you to go to find this paper and read this paper. So we will use the self-attention method in our method, in the method of our paper. So now we will talk about the datasets. So as I said before, we have got 2 large-scale datasets, and we want to make a new dataset on top of these 2 datasets. So we have got target image. We need target images, target group, and reference images, context group, and ground truth caption for our target image target group. So the first thing we will do is we will take an image and like this, and we will get the description of the image: a woman in a chair by the lake reading, or caption of the image. And after that, we will use this caption as an input to our language parser to parse the description or the caption, and we will get this scene graph. And the main part of the scene graph is woman in chair, as we see here. So the other words are the additional descripting parts. So we will use this main scene graph as a to make our target images. So we will get all the images with woman in chair, and also we will group them together, and we will group the other overlapping scene graphs together, so like this, and we will have woman. So this will be reference group, and the target group will be woman in chair, a particular group within the context. And they have created 2 200,000 samples using conceptual captions, and they have also created 146,000 samples using the stock captions dataset. So let's talk about problem setting and baseline. First of all, we have got let's say 5 target images. In our case, we have used 5 target images and 15 reference images, and our task is we have to generate a description to describe the target image group in the context of reference group. So first of all, what we will do, the first thing we will do is we will use these images. We will take these images as an input to our pre-trained ResNet model. Pre-trained ResNet model is pre-trained on ImageNet dataset, and we will get our feature maps for each of the images. And we will do the same thing with our reference group, and also we will get the feature maps for each of our reference images. And after that, so we have got two group of feature maps, target group feature maps and also reference group feature maps. And the one approach, naive approach, would be just summarize and concatenate by averaging. So first of all, we would sum up all the feature maps of target image group, and we would divide it by the number of images, in our case, which is 5 here. And in the case of reference group, we will sum up all the feature maps of reference images, and also we will divide it by 15, and we will get 2 feature maps, distinct feature maps. And after that, we will concatenate them together, and we will use this concatenated feature maps as an input to our LSTM model to get our description. This is like most how to say naive approach, the straightforward approach to do this kind of problem, to tackle this kind of problem. So actually the authors of the paper, they have come up with a better idea, and they have used self-attention and context contrastive features. First of all, they have done feature aggregation with self-attention. As you see, we have got target group and context group, and we will get feature maps here and self-attention and so on, and we will talk about them in detail in the next slides. And here in the next part, we have got group contrasting. So we will get like this 4 vectors, and we will concatenate them together, and we will use them as an input to our LSTM model to get our description. Well, in the next slides, we will be talking about each part of this method by one by one. So first of all, we have got image groups, 2 image groups, target group and the context group. Target group 5 images and the context group 15 images, and we will use them as an input to our ResNet 50 model to get our feature maps. These are Phi-T1, Phi-T2, Phi-T-N, and Phi-R1, Phi-R2, and Phi-R-N. These are the feature maps of the groups, and after that we will use these feature maps as an input to our self-attention model. And here, just for reminding, this is our self-attention model, and these are the feature maps are our inputs like this, and we will get this y1, y2, and y3 like this. So next, after using self-attention, by using self-attention, we will get this attention vectors like this for each group, target group and context group, for each image. After that, we will average for every group the attention vectors. We will add them, and we will divide it by the number of images, which is 5 here and which is 15 here in this case. And also we will use these 2 feature maps. We will concatenate them together, and we will use self-attention again, and we will get this concatenated attention weights or attention vectors, and again we will average them by the number of images, which will be 5 plus 15, 20. So we will divide it by 20, and we will get phi prime of c, and according to the authors this gives the similarity vector of these two groups. So we have got phi prime of t, which is the uh, attention weights of this target group, and also phi prime of r, which is attention weights of context group, and also phi prime of c, which is the similarity of these two groups, similarity attention. And after that we will use phi prime of t and phi prime of r like this to create our group representation, and also we will subtract this similarity vector, similarity attention weights from each of these groups, target group and reference group, to get our contrastive representation. So we have got here four vectors. So we will concatenate these four vectors and we will use it as an input to our LSTM model, and as a result in the end we will get this kind of description, woman with cowboy hat. So this is the overall method, how this method works. And let's talk about experiments. Well, there are two main datasets, conceptual dataset and stock datasets, and also they have used the previously existing metrics such as word accuracy, side error, word error rate, blue, and so on. So as I mentioned before, this paper is proposing a novel model, novel problem. So before this paper there was not any model or any paper proposed. So they are doing ablation study, like they are switching off or turning off different parts of their model and trying to understand how this particular part of the model is affecting to the overall performance of the model. So here, for example, they are using per image caption only, and they are using average captioning. They are using only average, the baseline that we have discussed in the beginning, and also they are using all the self-attention as an input to the LSTM model, and after that they are using average plus contrast as an input to LSTM model, and in the end they are doing self-attention plus contrast. And as you see here, in all metrics you can see that self-attention plus contrast is giving the highest result in both of the data sets. And also per image captioning is not giving any result here, as you see it's so low. So it means that per image captioning or per image caption, how to say, summarizing the each image's captions will not work good with this kind of problem. So in the next slides we will talk about the effectiveness of each parts of the method they are using. Let's talk about the effectiveness of self-attention on feature aggregation. Here we have got two image groups, A group and B group, and we are trying to understand the contribution of each group that's giving us or contributing to the overall attention. So images with more recognizable features get higher attention weights, thus contribute more to the aggregated group representation. Indeed, as we can see here, we have got two images here, the image 2 and 3, and we have got balloons. All the images have balloons with women, and as the size of the balloons are bigger than other images, so these two images are contributing more attention to the overall attention. And also here, as you see in the image 5, this image is bigger, and so this image will be more representative for this image group, so it's contributing more attention to the overall attention. And also as I mentioned before, the authors have used 5 target images and 15 reference images, but before deciding to do so, they have tried multiple number of images for each group. For example, first they have tried only reference images 15, and after that they have tried only one target image and 15 reference images, and 3 15 and 5 0, and also 5 15. And as you see, when they give these 5 target images and 15 reference images, they are getting the highest results, the better results than other ones. So they have decided to use this 5 target images and 15 reference images. And also we have to understand the role of contrastive representation and also group representation. Here they are using group representation, like only self-attention part, and they are using this self-attention weights as an input to their LSTM model, and they are getting woman, girl, and woman, which is like a summarize of the two groups, which is correct: woman, girl, woman. This is a just context description, and they are using only the contrastive part, the second part of the method, which is the difference of two image groups, and they are getting this kind of results: country with cowboy, straw hat, and white, real white, and is going boxing. As you have noticed, there are some grammar problems, mistakes, and so it means that it's working good. And also here, contrastive plus group, when they are using both of them, they are getting good results, like woman with cowboy hat, white girl, woman in boxing glove. There is no any grammar problem, mistake. So we are achieving the best result when we use contrastive plus group representations. And in the end, I would like to say that in this paper the authors have proposed a new task, context-aware group captioning, which was not proposed before. And also, to tackle this problem, they have created two datasets: conceptual captions and stock captions, for future research in this field, in this particular problem. And also they have created a new framework to tackle this problem using self-attention and contrastive representations. And on the right side you can see the results of their model. And let's see, the ground truth for this image group is baby on white background. This is the target image group, and this one is the reference image group, 15 images and 5 images. And the prediction of the model says baby on white background, and the prediction without context, when they are not using context image group, they are getting baby toddler. So you can see the same trend on the next group of images, and they have got ground truth woman lifting weight, this one, and the prediction of the paper is woman working with dumbbell, and prediction without context is fitness woman. So when they are not using this context image group, the context image group, they are not getting the desired result. But this using context image group is helping to get our result, like this woman working with dumbbell and woman lifting weight. They are like so close in meaning, in a grammar way too. So that's all for today, and if you have any questions, I would be happy to answer your questions. You can email me to this email address. So thank you very much. Bye bye.